Hi everyone, it's Ian here from Crack Maths, and in this video we are completing Paper 1 version 1 section B, which is the calculator version. This paper has been made in the style of an Edexcel paper, and so as of such it's an hour and 30 minutes, and it is out of 48 marks. In functional skills, in order to pass the paper, you need to get 36 marks out of 64, and that's spread across the two papers. So this paper is 48 marks, and the non-calculator section makes up 16 marks. So out of this 48 marks and the 16 marks from the other paper, if you want to get a pass, you will need to get 36 of those marks. Key things to note for this paper is that calculators may be used because part of it being the calculator paper. And we take the value of pi to be 3.14, okay? And that's particularly good to note because although the calculator has the pi button, for ease within functional skills, it's just easier to use the 3.14. Okay, so let's take a look at the first question of this, okay? Right, okay, so question 1 is saying here is a data set, and then we have a list of numbers, and the question says find the median. Okay, so we'll know that from tutorial 61, the median is the middle number when the numbers are in order. So the first thing that I need to do is put these numbers in order. So I can see that the smallest number is 1.9, and then I'm going to cross that off. Then the next smallest number is, actually it looks like it's that 2.5, so I'll cross that off as well. The next smallest number after that, I can see it's this 2.9 here, so cross that off and write that down. Then we've got no more 2s, so now we're looking at the 3s. I can see we've got a 3.3 here and a 3.3 here, so I'm going to write both of those down. And now what we've got one last 3, we've got a 3.5, and then I can see we're onto the 4s. So with the 4s, we've got a 4.1, and then we've got a 4.6, and then we've got an 8.1, oh, and an 8.2, which we're fitting just inside that box. So that's very good. Right, so now what we need to do is we need to find the middle of these numbers. So I'm going to quickly just count how many numbers there are. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 numbers there, okay? So let's just double check that there was 10 numbers in the list as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great, so I've got the same numbers in my list as was in the original list. Now, if there's 10 numbers, the way that we can identify the middle number is by doing 10 add 1, which equals 11, and then 11 divided by 2, which equals 5.5. So I know that the middle number is going to be in the 5.5 position, which means the middle value is here. So that's between these two numbers here. Now, if there's two numbers in the middle, we then need to find the middle of those two. And the way that we do that is we add them together and then divide it by 2. So I'm now going to do 3.3 add 3.5 equals 6.8. And then 6.8 divided by 2 equals 3.4. Okay, so there we go. That's the first question done, 3.4. Remember, if you need any extra work on the median, you can always visit tutorial 61 from the 70 tutorials covering everything you need to know. Remember, I've put a note in the description of this to say which questions link to which tutorial. So remember, if you need any help, just check there and then you can go through that afterwards. Let's now have a look at part 2. Part 2 of this question says, find the mode. Now the mode is the most common number. Now, luckily, because in the last question we put these numbers in order, we can actually see quite easily which number is the most common because it will be the numbers in the list where there's the most consecutive of that sort. So if I have a look here through this list, I can see that the first time that there is more than one number in a row, it's here, where we've got these two 3.3s. So that means that the 3.3s are going to be the mode, because that is the most common number, because it appears twice. No other number appears more than once, so that's that. And remember, if you want more work on the mode, that's tutorial 60. Okay, let's now look at the next page. So question 2 says, Brian buys 10 multi-pack bags of crisps for £2 each. There are 18 individual packs of crisps in each multi-pack. Brian is planning on selling the individual packs for 40p a bag. Work out how many individual packs he needs to sell to cover his initial spend. Okay, right. So there's several parts to this, okay, that we're going to need to make sense of. But what I'm going to focus on first of all is the question. So the question's asking, work out how many individual packs he needs to sell to cover his initial spend. So for me, the first thing I want to work out here is, what is his initial spend? So I know that one multi-pack costs £2 and he buys 10 of them, okay? So he buys 10 multi-packs. So I know to go from one multi-pack to 10 multi-packs, we times by 10. So that means to go, because each of these multi-packs comes with a price of £2, this is directly proportional. So we've got to multiply this £2 by 10 as well, and that will give me £20. Okay, so I now know that the initial spend is £20. Right, so now I need to work out how many 40p's go into £20, okay? Because that's how many packs of crisps he's going to have to sell to make his initial spend. There's several ways I could do this. I could actually just count up. So I know we've got 40p, we've got 80p, we've got £1.20, we've got £1.60, we've got £2, okay? And I could keep going that way. But that way would be quite slow. The quickest way I'm going to do, and which I'm going to do now, is if we were going to just simply work out how many lots of 40p makes up £20. Now, in order to do this, we need to get our units in the same measure. So currently we've got pounds here and we've got pence here. So that's a little bit tricky. So what I need to do is I'm going to convert this 40p into pounds. So I know that 40p equals 0.4 pounds. I'll put the pound sign there. So what we're now looking at is we're looking at if one bag equals 0.4 pounds, okay, or 40 pence, we want to know how many bags we're going to need to get up to this £20. Okay, so we want our bags to be worth £20. So we're looking at, what do we multiply 0.4 by to get to 20? So something times 0.4 equals £20. Right, now, in order to work this out, this is where our reverse calculations come in handy. Okay, so remember, if two things multiply together to give one thing, that thing divided by either of these two things, in which this case I'm going to pick the 0.4, will equal the other thing. Okay, so let's have a look at this. I can do this on my calculator because this is a calculator paper. 20 divided by 0.4 equals 50. Great. So here we go. This equals 50. So it's going to be 50 bags. So this value here equals 50. And that means we times this by 50 as well. So it's 50 bags. Right, now you're often asked to use reverse calculations to check your working. So what I'm just going to do is I'm just going to check that 50 times 0.4 equals 20. Okay, because if it does, then I know that we're correct. So I'm just going to do here 50 times 0.4, and it does equal 20. Right, so I can definitely put 50 bags here. So in this answer bit, I can write 50 bags. Right, okay, here we have question 3. Question 3 says, Lola works for Maths Town Council and has drawn a scatter graph to compare traffic collisions with the temperature on the day they occurred. Right, yes, this is correct. So we can see that this is a scatter graph with traffic collisions on the y-axis and temperature on the x-axis. Question A says to complete this table. Okay, so let's have a look. In order to complete this table, what we're going to have to do is we're going to have to identify the points that have been plotted here. So we can see on this table here that all of these coordinates, okay, kind of match up. I can see here that this 2 is linked to this 48. So if I look along the bottom axes, I can see that each one of these squares is going to be 1. And I know that because there's 5 squares and every 5 is called 5. Okay. Now, here though, on the y-axis, it's going to be a little bit different. So if I look at this one, if I'm just taking this one as an example, I can see that this is 2 and this one is 48, okay? And that makes sense here because I can see that each one of these little ones here is going to be 2. And that makes sense because I can see that 5 squares equals 10. So 1 square equals 2. So this is important for when we're reading here. So we need to remember that 1 square on the y-axis is worth 2 and 1 square on the x-axis is worth 1. Okay, right, let's get started with filling out this table. First one is at temperature 0. Okay, temperature 0. So we're trying to work out where that point is. So here we go. Here's the point that's at temperature 0, and I can see that that is 50 collisions. So I'm going to put a 50 here. Right, the next one we've got, okay, right, we've got a 48. Now we know that this one was the 48 too. So we're going to look at this one here, which is going to be 48, 4. So I'll put that in my table. Next, what I've got is I have got this blank over here. And this was when the temperature was 13 degrees. So if we look over here, we can see 13 degrees here. And then if I read up, I can see that there's 2 options here. And let me just see, there's 2 13s in this table as well. And I can see one of those 13s is with a 35. And that would be this one. This is the 35. So we need to know the coordinate for this one here. So it's 1 square above the 30 line. So this will be 32. Right, now let's have a look at this last one here. So we've got 21 collisions. So we're at 20 and we're going to go up half a square because remember, each square is worth 2. So if we go up half a square and read over, we can see we've identified this here. So let's have a look and a read down. Okay, if I read down from here, I can see that this is 21. Ah, right, that's nice. So it's 21, 21. Okay, great. Let's now have a look at part B. Okay, so part B says, describe the relationship between the number of recorded traffic collisions and the temperature on the day they occurred. Okay, so I can see that, if I go back to the graph, as the number of collisions goes down, the temperature increases. So we can see here, because over here, the coordinates have a higher temperature and a lower number of collisions. And then over here, we can see that they've got a higher number of collisions and a lower temperature. The name for this type of relationship is called negative correlation. And that's when the 2 things are doing different things. So when one thing's going up, the other's going down. And when one thing's going down, the other's going up. So this was a negative correlation. So I'm going to write that down here. Negative correlation. Okay, great. Let's have a look at the next question. Okay, so here we go. For this question, it says, question 4. Suki buys a brand new car for £16,000. She read that a car depreciates in value by 12% after 1 year and then by 7.5% each following year. Work out how many years it will take for Suki's car to be worth less than £12,000. So for this question, I am going to use my percentage equivalent decimal multipliers, or my decimal equivalent percentage multipliers, because it's the calculator paper, and this is by far the fastest route. So I can see I want to reduce £16,000 by 12.5%. Okay, so I'm looking for, if I'm making that reduction, I'm going to do 100%, take away 12.5%, and that equals 87.5%. So I'm looking for, in the first year, I'm looking for 87.5% of the original cost. So in order to find 87.5%, I do 87.5 divided by 100 to convert it into a decimal, and that gives me 0.875. And then now I know anything I multiply by 0.875 is going to be reduced by 12.5%. So I'm going to just do 16,000 multiplied by 0.875. Right, okay. I'm going to work this out because we're going to need that number. And that equals 14,000. Okay, now what I know is for the next 2 years, I'm going to have to reduce this £14,000 by 7.5%. So 100% minus 7.5% equals 92.5%. And now what I need to do is 92.5 divided by 100, and that equals 0.925. So I know now that anything I multiply by 0.925 will be reduced by 7.5%. So what I need to do is I need to just keep on now multiplying by 0.925 until my answer becomes less than 12,000. So let's first of all try doing that once. So remember, I'm doing this on my calculator. 14,000 times 0.925, and that equals 12,950. Okay, now as that is not yet below 12,000, I need to do that again, but luckily we're still doing the same reduction, so I can just multiply this answer by 0.925, and that equals 11,978.75, and that value is less than £12,000. So I can see it took 1 year to get to 14,000, 2 years to get to 12,950, and 3 years to get to 11,978.75. So I can see that it takes 3 years for Suki's car to be worth less than £12,000. So I'm going to write that in the box at the end. And remember, there's loads of ways to do percentage decrease or percentage increase. It's all just basically different methods of applying percentage of an amount. So if you want more work on how to find percentage increase and decrease and stuff, or compound interest actually, which this is a form of, you can find those at tutorials 32 and 11. But remember again, that's down in the description if you need a point of reference to those later. Okay, let's now look at question 5. Okay, right, so let's have a look through question 5. And that says, here is a plan view of a bathroom floor. So, quick reminder there, a plan view means the view from above. The floor is a rectangle with a semicircle cut out for the bathtub. The measurements are in meters. Using y equals 0.5, calculate the perimeter of the bathroom floor. Give your answer to the nearest meter. Right, okay, so what I need to do here is I'm going to need to, first of all, work out what these measurements are. So I can see I've got 3y here, and I can see that I've got 5y here, okay? Now, so if this is 3y, and this is 5y, and I'm told that y is equal to 0.5, the first thing they expect us to know here is how to substitute this value into these expressions. So 3y means 3 times y, okay? And as I've been told that y is equal to 0.5, this equals 3 times 0.5, and that equals 1.5. So that means that this measurement is 1.5 meters. And now with the 5y, let's do the same thing. I've got 5y equals 5 times y, and that means that this is 5 times 0.5, and that equals 2.5. So I know that this measurement here is 2.5 meters. As this is largely a rectangle, well, it is a rectangle with a semicircle cut out, what we can do is we can now use that knowledge to fill in some of these other lines. So we do know with rectangles that opposite sides of the rectangle are the same length. So if this is 2.5, that means that this length is 2.5. And if this length here, from here to here, is 1.5, I know that this length here is 1.5 meters as well. So we've actually now got 3 of the sides done. The main thing that we have left is this circular bit. So we need to work out this bit here, okay? Now, the way that we're going to do that is we're going to need to find out the circumference of the circle that this is a semicircle of, okay? So I'm going to draw a circle as if that was the whole circle, and I can see here that we've got this diameter of 1.5. Now, what you're going to need to remember for this question is the formula for the circumference of a circle. So if you can't remember it, the circumference of a circle equals pi times the diameter. And remember, pi equals 3.14. So the circumference of this circle is going to be 3.14 times by 1.5. Okay, I'm going to do that on my calculator. So we get 3.14 times by 1.5. and that equals 4.71. Now, what we have here, this 4.1 refers to the circumference of this whole circle. Now, because we have the semicircle, we only want half of that. So I'm going to now do 4.71 divided by 2. And again, I'm going to do that on my calculator. So 4.71 divided by 2, and that equals 2.355, and that's meters. So now we have all of the measurements of this perimeter. We've got 2.5 here, 1.5 here, 2.5 here, and then this bit here, this curved bit here, is this 2.355. The perimeter refers to the distance around the outside of the shape. So in order to get the perimeter of this bathroom, we're going to need to just add all of these together. Okay, so I'm going to write that down because remember it's important to do your working out. So I'm going to write down 2.5 plus 1.5 plus 2.5 plus 2.355, and I'm going to work that out on my calculator, and that equals 8.855. Now that's 8.855 meters. Now the question here asks us to give your answer to the nearest meter. So I know that 8.855 is going to round up to 9 meters. So in my box, I'm going to write down here 9 meters. Okay, great. If you want more work on that question, that was question 5. And question 5 is closely linked to tutorials 7, 43, and 46. Okay, so that's where you need to go if you want to practice that. Okay, let's now look at the next question. Okay, so question 6 says, write 0.72 as a fraction in its simplest form. You might be able to spot this straight away, but for those of you that can't spot it straight away, I'm going to go through a method that I like, just to kind of keep this simple, because this one is there's 2 decimal places, so you might instantly recognize this from your work on percentages and decimals, okay? But if you don't, I'm going to go through this method. So every number in life is a number over 1. We just don't bother writing it, okay? Then, using equivalent fractions, what we can do is we can times up by powers of 10, okay? Because that's how we shift numbers over. So whenever a number reaches 10, it goes up. So if I've got here 1 times 10 is 10, 0.72 times 10 will be 7.2. Okay, I can do this again, and that gives me 100, and that gives me 72. So I can see here that 0.72 is the same as the fraction 72 out of 100. However, they want the simplest form, so that means that I need to divide this 72 and this 100 by whatever common factors they have until there is no more for them to be simplified. So, like in the same way where we were timesing by the 10, the fraction was fine because we were doing the same thing to the top and the bottom. So now what I need to do is I go 72 over 100. I know these are both even numbers, so I'm going to divide both of these by 2. Okay, so that gives me 36 over 50. I can see that they're still both even numbers as well, so I'm going to divide them both by 2 again, and that becomes 18 over 25. Now, there's nothing more I can actually do there, because if I look at both of these numbers, neither of them divide, well, 18 divides by 2, but 25 doesn't. 18 divides by 3, but 25 doesn't. 18, neither of them divide by 4. 25 divides by 5, but 18 doesn't. 18 divides by 6, but 25 doesn't. Neither of them divide by 7. Neither of them divide by 8. 18 divides by 9, but 25 doesn't. And we've got over half of the way there to 18, so actually there's going to be nothing that either of them share as a divisor. So that means that this 18 over 25 is now in its simplest form. So I can write that in my box. Okay, let's have a look at part B. So here we go. Part B says, evaluate bracket 6 minus 1 cubed minus 2 times bracket 4 plus 3. Right, okay, so the most important thing to remember here is that we do the brackets first. So let's get the brackets out of the way, and then we'll worry about the rest. So 6 minus 1 is 5. So this becomes 5 cubed minus 2 times 4 plus 3, which is 7. Okay, right. Next things that we do is we do the indices. Okay, 5 cubed means 5 times 5 times 5. Okay, so 5 times 5 is 25, times 5 again is 125. So that becomes 125 minus. Now, we do in maths, we do the multiplications before the takeaway. So what I'm going to do here is I'm going to do this 2 times 7 now. So 2 times 7 is 14. So this sum becomes 125 take away 14. Okay. Now 125 take away 14 is 111. Remember, you have your calculator. So if you wanted to do any of this on your calculator, you could. So I'm going to put that in my box there as my answer, 111. Okay, let's have a look at the next question. Right, so here we go. We've got question 7 here, and it says Julian is making margaritas. He uses tequila, orange liqueur, and lime juice in the ratio 3 to 2 to 1. Julian has 1 litre of tequila, 750 mils of orange juice, and 0.5 litres of lime juice. Find the maximum margarita mix Julian can make. Right, okay. So this question is largely going to be a question of trial and error because we've got 3 ingredients here and we've got the ratio, and we want to know the maximum amount of the mixture for margarita that we can make. So what that means is we've got to experiment with using up each of these ingredients. So there's going to be one scenario where we use up all the tequila. And if we use up all the tequila, we've got to check that we've still got enough orange and lime for that to be okay. Or we've got a situation where we use up all of the orange liqueur. And if we use up all of the orange liqueur, we need to check that we've still got enough tequila and enough lime juice for that to be okay. Or lastly, there could be the situation where we use up all of the lime juice. Okay. And if we use up all the lime juice, it will have to be that we've still got enough tequila and enough orange liqueur for that to be the case. Okay, this sounds more confusing than it is. So what I'm going to do is I'm going to get started. But actually, what I've noticed here is the first thing we need to start on is making sure all of our ingredients are in the same unit. So we've got here 1 litre, 750 mils, and 0.5 litres. So I'm going to convert everything to millilitres because although the numbers will be a bit larger, they won't be decimals. So I think it will be a bit easier to follow. So I know that 1 litre equals 1000 millilitres. Okay. So if 1 litre equals 1000 millilitres, that means that 1 litre of tequila will be 1000 millilitres, and 0.5 litres is going to be 500 millilitres because 0.5 is half of the whole. So 1000 millilitres divided by 2 is 0.5, yeah, 1000 millilitres divided by 2 is 500 millilitres. Right, now what I'm going to do is I'm going to write down this ratio. So we've got tequila to orange to lime. Okay, so tequila to orange to lime is 3 to 2 to 1. So tequila to orange to lime is 3 to 2 to 1. I'm going to go for scenario 1 first, which is where we use up all of the tequila. That means that I'm going to need 1000 millilitres of tequila. If this works, if I'm able to use all of my 1000 millilitres of tequila, that will mean that I need to still have enough orange and enough lime. So if I don't, with using 1000 millilitres of tequila, I don't have enough orange or lime to do that, then this will not be the solution. Okay, so I know that the ratio is 3 to 2 to 1. I want to get to 1000, so I need to know how many lots of this ratio I'm having. So remember, I'm timesing this by something. So something times by 3 equals 1000 millilitres. So now what I need to do is my reverse calculation. So 1000 divided by 3 and find out what that equals. So that equals 333.3 recurring. So this little dot here means that those 3's go on forever. So I know that to use up all of the tequila, we're going to use 333.3 recurring lots of the ratio. So I need to times the orange by that and the lime by that. So 2 times 333.3 recurring gives me 666.6 recurring. And then 1 times 333.3 recurring gives me 333.3 recurring. And I can see that I have enough orange liqueur to do this, and I have enough lime juice to do this. So actually, that's pretty lucky because that means I'm at the answer. So what I now know is that if I use up all of the tequila, I need 666.6 recurring millilitres of orange and 333.3 recurring litres of lime. Now, the question asks, find the maximum margarita mix. So what I've got to now think about is if I've got my jug, say I've poured in my tequila, now I've got to add my orange, add my lime, so I want to know what is the total measure of this. So to do this, I simply add my three values together. So I do 333.3 recurring, add 666.6 recurring, add my 1000, add my 1000. I'm going to do that on my calculator, and I know that that equals 2000 millilitres. Right, so I know that I've got 2000 millilitres here. Now, 1 litre equals 1000 millilitres. So if I've got 2000 millilitres, I can see that this is 2 lots of that. So I know that that will be 2 litres. So I can write here 2 litres. Okay, perfect. Let's look at part B. Part B says, work out how many 120ml glasses this will fill. Okay, so if I know that 1 glass equals 120ml, I want to know how many glasses gets me up to 2000ml. It might be that it's not an exact number, we're going to find out. So how many lots of 120ml go into 1000? So that's what I'm looking at. 120 times something equals 2000. So remember, I've just noticed here, we've got this here, reverse calculation. So remember your reverse calculation. If two numbers multiplied together to give something, then that something divided by either of those two numbers gives the other number. So we can do 2000 divided by 120, and that equals, I'm going to do that on my calculator, 16.6 recurring. Right, now, as this is how many glasses will this fill, we're not going to fill 17 glasses because we don't have enough. So we're going to have to give the answer of 16. So there we go. We know that this amount of mix will fill 16 glasses with a little spare. Part C says, use a reverse calculation to show a check of your working. So what that means is, remember that we've got this here. So we worked out that 2000 divided by 120 equals 16.6 recurring. So the reverse calculation that we can do to check that is going to be 16.6 recurring multiplied by 120 and check that that equals 2000. So remember, I'm going to do that on my calculator. So 16.666666666. I'm just going to keep going for a little while. Times 120, and that does equal 2000. Okay, so that is a satisfactory check, and it does mean that I'm confident that I've got section B correct. Right, let's look at the next question. So here we go, we've got question 8, and question 8 says, Ava is considering joining a film club. She sees 2 membership deals. Deal 1, which is £60 annual payment, 12 free tickets, and 30% off cinema tickets. Or deal 2, which is £11 per month, unlimited free tickets, 1 year minimum subscription. Tickets to the cinema usually cost £8.50. Ava thinks if she goes to the cinema twice a month for 10 months a year, deal 1 will be cheaper. Is Ava correct? Show why you think this. Okay, so what we're going to have to do here is we're going to simply have to work out how much money Ava will spend with both of the deals. So to me, it looks a lot easier to calculate how much deal 2 is going to cost. So I'm just going to work out the cost of deal 2 first. So deal 2 is £11 per month, and that's for 1 year. So I'm going to do 1 month equals £11. So then we want 12 months. So I'm timesing that by 12. So 11 times 12, and that's going to be £121. So I know off the bat that deal 2 is going to cost £121. Now remember, you've got your calculator, so if you want to do any of those things on your calculator, you can. But now let's have a look at deal 1. Right, so deal 1 is going to be a bit trickier because we've got to work out some things. First of all, before we work out deal 1, I think we need to work out how many tickets a year does Ava intend on buying. So Ava thinks she will go to the cinema twice a month for 10 months, okay? So twice a month for 10 months. So 1 month equals 2 tickets. So 10 months equals, right, times that by 10, times 10, times 10, 20. So Ava's looking to buy 20 tickets. So let's first have a look. So £60 on this deal. Okay, so £60 is going to get her 12 tickets. So that's 12 tickets. So we want 20 tickets. The £60 gets you 12. So we can do 20 take away 12 equals 8 tickets. Okay, so we're looking to buy 8 tickets. Right, now, we know we get 30% off cinema tickets with this deal. So what I'm first going to do is work out how much these extra 8 tickets cost without the discount. And then I'm going to apply the discount so we know how much she's going to have to pay for her extra 8 tickets. So let's have a look. So tickets to the cinema cost £8.50. So we need 8 times £8.50, and that's going to give me £68. Oh, it's going to be close. So now what I need to do is I need to reduce that by 30%. So remember, if you want to reduce something by 30%, you're effectively looking for 70% of the cost. So 70 becomes a decimal equivalent multiplier of 0.7. Okay, so now I'm just going to do 0.7 times 68. Okay, 0.7 times 68. And that equals 47.60. So now what we need to do is we know it was £60 for the 12 tickets, 47.60 for the extra 8 tickets. So if I add those together, so if I do 47.60, add 60, that equals £107.60. Now, £107.60 is less than 121. So let's see, what did Ava think again? Ava thinks if she goes to the cinema twice a month for 10 months a year, deal 1 will be cheaper. And she's right. She is correct. So we can say yes. Show why you think this. Now, the way that we've shown it is through our working out. So as long as you've written you're working out neatly and you can kind of see what's gone on, that is a perfect explanation. Okay, right. Let's now go on to the next question. So here we go. We've got question 9, and it says, here is a grid with points G, H, and I plotted. Write down the coordinates. Oh, sorry about that. There's a bit of a typo here. Don't worry, that will be changed. Write down the coordinates of point G. Okay, so here is point G, and I can see if I look here, we've got an X coordinate of -1, and we've got a Y coordinate of 5. So the points of plot G are going to be -1, 5. So remember, we always write our coordinates alphabetically. So here we go, we've got -1 and 5. Right, on the grid, mark point J such that all 4 points join together to make a parallelogram. Okay, right, so we've got 1, 2, 3 points here. Now, a parallelogram is a shape, it looks like the pushed over rectangle. So we've got to have opposite sides of the same length, and we've got to have the lines going parallel to each other. So if I can see here that this is the top line of the parallelogram, I can see that that is 3 squares. So what I've got to do is I've got options here. I've got to go either 3 squares this way, or if I wanted, I could go 3 squares this way. And then when I join these up, both of these shapes are a parallelogram. So I could make my point here, or I could have made it on the other side. Okay, so there we go. Mark on point J. There we go. I've marked point J on. You should label it so that it's nice and clear. So they're all the points joined together to make a parallelogram. Great. Okay, right. Let's go look at question 10. Right, so here we go. Question 10 says, Bob monitors the attendance at a nightclub. On Friday, the attendance is 1,024. On Saturday, the attendance is 1,472. Calculate the percentage increase in the number of people attending from Friday to Saturday. Give your answer to one decimal place. Right, okay, percentage increase. So we're going from Friday to Saturday. So the percentage is going to be out of the Friday. So first of all, let's actually work out what the increase is. So we increased from 1,024 to 1,472. So we've got to do 1,472, take away 1,024, and that equals 448. Okay, so that was the actual increase. So it's 448 out of a potential of 1,024. So we then do this, divide this, and then times this by 100, and that will be our percentage increase. So 448 divided by 1024, okay, times 100, and so that equals 43.75%. And I'll rewrite that in this box here just to make that nice and clear. Okay, let's look at this extra information down here. So Bob records the attendance for 10 weekends. He finds the following. Friday has a median of 920 and a range of 234. Saturday has a median of 720 and a range of 1,205. Bob says that the busiest day was a Saturday. Is he correct? Explain your answer. Right, so for this, we've got to kind of remember what the median and what the range means. So the median is the middle value, and the range is the difference between the largest value and the smallest value. In theory, it is possible that the median is also the smallest value or the largest value, depending on if a lot of the values are the same. So, in theory, if the median for Friday happened to be the smallest number of people that attended on Friday, then the maximum number of people that could have attended on Friday is going to be 920 plus 234. So let's work out what that would be. So that equals 1,154. So this is the maximum people that could have attended on Friday. Okay, now, so this is the maximum number that could have possibly attended on a Friday if the 920 was the minimum amount of people that attended on Fridays. So now what we've got is we've got to look at this Saturday. Now, the range for Saturday is 1,205. Okay, now the minimum number of people that could have attended on a Saturday is 0. Okay, you couldn't get a negative amount of people. So therefore, if no people attended on that Saturday, the smallest value that the maximum number of people could be, so in other words, the minimum maximum number of people would be 1,205. As the range equals the largest take away the smallest, if no people attended one Saturday, the largest value would be 1,205. As 1,205 is still larger than 1,154, Bob is correct because the smallest, largest attendance for a Saturday would be 1,205. But the largest possible attendance for a Friday is 1,154. So therefore, Bob is correct. Okay, let's look at question 11. So question 11 says, Jim finds a table in a child development book. The table shows the running speeds of children. So we've got the table here, it's got the height in inches and it's got the speed in meters per second. Jim measures his child to be 67 centimeters. Jim wants to go to the shop 420 meters from his house. What is the fastest he can expect to get to the shop if his child runs all the way? Okay, right. So there's a couple of things that we've got to do here. first of all, we need to work out which height category Jim's son falls into. And then once we know that, we've then got to work out how fast he could potentially go to the shop, knowing how many meters he can travel in 1 second. So first of all, let's convert Jim's son's height into inches. So I'm going to write this formula like this. I'm going to put it this way around, say 2.54 cm equals 1 inch. I'm then going to change this so that I know how many inches 1 centimetre is. So because lengths are directly proportional, I just divide both sides by 2.54. And so 1 divided by 2.54 equals something long. But I'm just going to keep that number in my calculator. I will write it down. I'll write a bit of it down here. So 1 centimetre equals 0.393700 inches. So I want to know 67 centimetres. So now what I've got to do is I've got to times this by 67, and I have to times this by 67 as well. Okay, so if I do that times 67, what I get is 26.4 inches. Okay, so I can see that 26.4 would land you in this group. And so knowing that, I can see that Jim's son will be predicted to be running at 3 meters per second. Now, that means in 1 second, he runs 3 meters. So I want to know how long it takes him to run 420 meters. So I need to multiply this by, well, I need to work out what I want to multiply that by. So I'm just going to do 420 divided by 3 to find out what that is. 420 divided by 3 is 140. So 420 is 140 lots of 3 meters. So that means it's going to be 140 lots of 1 second. So he's going to be 140 seconds. Okay, so I know that Jim's son can run to the shop in 140 seconds. So I need to write this now in terms of minutes and seconds. So I know that 60 seconds is 1 minute. I've got 140 seconds here. So 60 seconds is 1 minute, 120 seconds is 2 minutes, and that's going to leave 20 seconds left. So this will be 2 minutes and 20 seconds, okay? So that's how fast Jim can expect his son to run. Right, I know this next question that's coming up, so I'm just going to remind us of this bit of information here. Jim's son is 26.4 inches, okay? On your exam paper, you'll have it on the same page, but here, because we're on the internet. So I'm just going to say 26.4 inches whilst I remember. Right, now let's have a look at this question here. Question 11 says, Jim does a survey of the heights of the other children at his child's nursery. He puts the results together in the following table. So he's got height here and inches. And then he's got frequency. Now, frequency just means how many. So this tells us that there was 8 people between 12 to 18. There would have been 4 people between 18 to 24, 10 people between 24 to 30, and 2 people between 30 to 36. Jim thinks his child is taller than the mean height. Work out if Jim is correct. Okay, so what this means is we're going to have to estimate the mean from this frequency table and work out if Jim's child, who is 26.4 inches, is above the mean or below the mean. So we've got to remember that the mean means everything added together divided by the number of things. So in this case, that's going to be all of the children's heights added together divided by how many children there are. So because we don't know the exact heights of any of these children, what we're going to have to do is we're going to have to estimate. So we know that there's 8 people, 8 children that are between 12 to 18 inches. So the way that we estimate what height they are is by kind of actually finding the average of these two numbers. So I'm just going to do 12 add 18 divided by 2, and that's going to be my estimate for the heights of these people. So 12 add 18. Okay, so I'm going to estimate that these kids are 15 inches. Okay, I'm going to do that for all of these here. So here I'm going to do 18 add 24 divided by 2. So 18 add 24. So this is 21. And then I'm going to do the same again. So that's 54 divided by 2. So that's 27. So this one will be 66 divided by 2, which will be 33. Right, so there's 8 children that are 15 inches tall. So I'm going to do 15 times 8, so that equals 120. I know that there's 4 children that are 21 inches tall, so I'm going to do 21 times the 4. That's going to give me 84. I've got 10 children that are 27 inches tall, so I'm going to do 27 times 10, and that's going to equal 270. And I've got 2 children that are 33 inches tall, so I'm going to do 33 times 2, and that will equal 66. So if I was to lay down all of these children head to toe, the first 8 would take up 120 inches, the second 4 would take up 84 inches, the third 10 would take up 270 inches, and the last 2 of them would take up 66 inches. So altogether, if I want to know how many inches they all add up to, so that everything added bit, I've got to add all of these numbers together. So I'm just going to do that quickly now. So 120, add 84, add 270, add 66. And so that equals 540. So here we go. We know that all of those kids together, everything added, their heights add up to 540 inches. Now, how many kids were there? Now, to find out how many kids were there, I just have to total up the frequency. So I've got here to do 8, add 4, add 10, add 2, and that equals 24. Okay, so in order to calculate the mean, I'm going to do everything added together, which is my 540, divided by the number of things, which is my 24. So 540 divided by 24. So, and that equals 22.5. And so what I can see from that is Jim's child was 26.4 and the average child was 22.5 inches. So is Jim correct? The answer is yes. Okay, great. And that takes us to our final question. Okay, so here we go, question 12. So question 12 says, Yvonne is making 250 spherical ice lollies for a party. She decides to make them with orange juice. She knows that the volume of a sphere is volume, V, equals 4 pi r cubed divided by 3. The diameter of the spherical mould is 5 centimetres. As the volume of orange juice will increase by 9% when frozen, Yvonne will need to underfill each mould accordingly. Orange juice is sold in cartons of 1 litre. What is the minimum number of cartons Yvonne needs to buy to make the 250 lollies? Right, okay, so there is a lot going on here, okay, but what is good to do with these things is not to get overwhelmed and just take them piece by piece. So the first thing I can see here is that Yvonne is planning on making 250 spherical lollies, and the sphere has a 5 centimetre diameter, and we've been given this formula here. So if I know that the diameter equals 5 centimetres, I can see that this formula uses the radius. I'm going to need to know that my radius is 2.5 centimetres, okay, because I've halved the diameter. We're going to have 250 lollies of this volume, okay, so I'm now going to work out what this volume is. So V equals 4 times pi, which is 3.14, times radius cubed, so that's 2.5 times 2.5 times 2.5 divided by 3. So I'm actually going to work this out in my calculator. So V equals 4 times 3.14 times 2.5 times 2.5 times 2.5. And then I'm going to divide that answer by 3. Okay, so here we go. This equals 65.416 recurring mils. Okay, right. So there we go. That's one part of this done. We know the volume of one sphere. Right. If this is the volume of one sphere, we want 250 spheres. So if I know that one sphere equals 65.416 recurring, I know that 250 spheres equals this times by 250. So I'll times that by 250 now. And so this equals 16354.16 recurring mils. Right, okay, here we go. So we've got 600, we've got the 250 spheres here. So this bit would get you 2 of these marks maybe, because you've substituted into the formula and you've multiplied it by the number that you want. Now what we've got to look at this next bit of information. So as the volume of the orange juice will increase by 9% when frozen, Yvonne will need to underfill each of the molds accordingly. So basically, we know that 100% plus 9% has to equal this value that we've got, 1635.4.16 recurring mil. Okay, we know that the amount of orange juice plus the 9% increase has to equal the total volume of all the spheres. So that's going to tell me that 109% equals 654.16 recurring mil. Okay, great. So now, if I now know that this is 109% of the orange juice, okay, because remember, the orange juice is the amount of orange juice that we buy is our 100%, and then that's increasing by 9% to fill up the volume. So the 109% of the orange juice is our total volume of all the spheres. Now what we want to do is we want to find out what the 100% of the orange juice is, so we actually know how much orange juice we need to buy. So if I've got 109% is this, what I've got to do now is divide both sides by 109 to find out what 1% is, and then I can go and times that by 100, and that will give me the 100%. Okay, so once I've stored the number on my calculator, so I'm now going to divide this by the 109. So 16,354.16 recurring divided by 109 equals 150.03822263. Now, if I times this by 100, I get 15003.8. Okay, I'm going to leave that there at the moment. So we know that we need 15,003.8 mils. Okay, right. Now I know that 1 litre equals 1,000 millilitres. So if 1 litre equals 1,000 millilitres, we've got 15,003.8 millilitres here. So if I want to convert this into litres, I'm going to have to divide this by 1,000. So remember, you can kind of hear the sound. If 1,000 is 1 litre, 15,000 is going to be 15.0038 litres. Oh no! So Yvonne needs 15.0038 litres. Okay. So the cartons of juice are sold in 1 litre cartons. So really, if we're truly honest here, Yvonne, if she only buys 15 cartons, is going to be 3.8 millilitres short. So technically, Yvonne needs to buy 16 cartons. Okay? Okay, right. There we go. And that's actually the last question. You'll notice on the past paper there was more space for that, but due to the screen, I didn't fill that out. But we could say here, yeah, so she needs to buy 16 litres of orange juice in total. So there we go. That was section B, and that was out of 48 marks. Well done if you've made it this far. If you've watched this and you've highlighted any of the questions that you need to work on, remember I have put the links to the tutorials that are relevant to each question in the description. So make sure that you go to them and have a look. If not, I have also put other versions of this paper on the website, so you can have a go at those. There might not be answers to them yet, but the answers will be coming soon. So make sure that you just stay alert, and hopefully they will be with you shortly. Thank you again for watching this video, and hopefully I will see you in something else. Okay, right, so long. Good luck, and see you soon. Bye.